How's it guys? It's Cassidy here from South Africa. I want to show you how to use Boardcad. I've been having quite a bit of trouble getting used to the setup, being able to use it for a CNC machine. But hopefully this tutorial can make it a little bit easier for you. So yeah, please stick with me and enjoy. So first of all, we got to download Boardcad. I've already done it, but let's just head over to boardcad.com. There we go. Alright, well, you can register on Boardcad, so you have access to posting on the forums if you need help. There's also one document on the Boardcad website, as they've created a new website now, the Boardcad book, which also has a lot of information on how to get started and how to use the software to the maximum potential. Is also not quite as available as it was, so I'll see if I can upload it for you. So let's go over to download and go to SourceForge, and over here we can download Boardcad 3.0.1. Go ahead there, wait 5 seconds, but I've already have it downloaded, so let me just skip straight to the business. There we go. Alright, so let's just install it over here. Alright, let's make changes. Let's go. Alright, I see I already have it installed. Let's just update the installation directory. No, it's pretty straightforward installing Boardcad. I'd suggest if you have been modifying files and trying to get your CNC stuff to work, it would be best to just uninstall Boardcad. Also delete the Boardcad directory from program files and then just reinstall it all, and you can continue with the tutorial from there. Alright, cool. So now that that has been installed, let's just quickly run it. There we go. Alright, so Boardcad is a little bit, how could I say, a little bit fussy in its ways. If it's not done pretty much exactly the way it should, then you could run into some errors. But it's pretty powerful, and of course it's free, which is the great thing. If you're looking at any other packages, it's definitely going to cost you quite a lot of money. Alright, so looking at the unit, I just want to change it to millimeters. That's my favorite. But also take note that all the configuration files are set up in millimeters. It's not dependent on this little box over here. Alright, so if we want to CNC something, of course, we first need to import our blank. Alright, so you can mock up your blank in Boardcad, save it as a board file, or you could do it in Shape3D's free version. Take note, it needs to be saved as a S3D file, not a S3DX. Alright, so here I've already created my board, but if you want to create a new one, you could just choose a template. So I'm just going to open mine. Alright, now take note of the open dialog. Alright, it's already gone to my boards folder. If in that folder that you're going to has a board file which is supposed to be compatible but not exactly compatible, for instance, the Shape3D boards with a fin box wouldn't open in Boardcad. Also, if there's a corrupted file, it would also freeze the open dialog, or an old Boardcad file or a new Boardcad file. It's quite sensitive to which files you have in your directory, otherwise the open dialog freezes up. Alright, so let's open up our blank. There we go. Alright, cool. So from here, the first thing we've got to do whenever we import a board is to go to 3D model and create 3D model using Bezier patches. Alright. If you've imported a model and it's not looking quite the same as it did last time you did it, it's most likely because the 3D model was not converted using Bezier patches. Alright, so now once it's all shaded, what we're going to do is we're going to render it as a NURBS model. There we go, I believe that's rendered as NURBS. Alright, so now we have our blank inside and we need to set it as a blank. So we'll go to 3D model, we'll choose set as blank, and then of course very important is to right click, view blank. Alright, now if this line is not blue, your board has not been converted to a blank successfully. Alright, so from now that you've converted it to a blank, now we can actually go and import our board file that we want to CNC. So I'll go open, I'll open this board. Just a little bit of a background on how the boards are cut that I'm doing is we're cutting it out of just a flat rectangular square blank of extruded polystyrene. And so what we do is we flatten the board out, or we design it in a flattened way, and then we press it into its own rocker. Also, our blanks do not have any stringers, but also makes the cutting process a little bit simpler. Alright, so I imported the board, but you can't see it, so that's a little bit misleading. So first, the reason why we can't see it is because it has not been created to a 3D model using Bezier patches. So now once we created it to a 3D model with Bezier patches, just if the block is indented or if it's highlighted, it means that the program's loading. So it's taking its time to process the board. There we go. Alright, our board's in. Brilliant. So now we need to shift our board a little bit in the blank so it seems a bit more reasonable. So what we'll do is we'll translate X, which is in the length of the board. Let's make it 25 millimeters. There we go. You can see the whole board is shifted that way. It takes a while to respond in this window. And then of course we want to shift it up a little bit higher in this block over here. So also go to 3D model, transform Y. Y is the thickness of the board in the modeling. So shift it 5 millimeters. Oh, it's maybe not enough. Let's do it again. 5 millimeters. There we go. Now it seems to be quite comfortably fitting inside our blank. Alright, and then we can also just render NURBS model. Alright, that's not all. What we need to do is we need to change quite a few parameters in our shapebot.properties file. So we'll head over to our local disk. We'll go to program files, x86, or if you're on a 32-bit system, it'll just be on normal program files. Alright, find Boardcad. Alright, but before we go into Boardcad, because we're inside system files, you need administrative privileges. So we'll right click on Boardcad, we'll go to properties, and we'll go to, there we go. Alright, we just want to edit some permissions here. So just want to click edit, and we allow everything for everybody. All users, we allow everything. Systems, everything's allowed. Owner, well, it's just allowed all. Alright, well, not exactly too sure everything I'm doing here, but I just want to click apply here. Okay, cool. So our settings have been changed there. So we're now allowed to change files, move files, create new files, edit files. Alright, cool. So the files we're looking for is down to bottom, shapebot.properties, shapebot3 bottom.py, and shapebot3 deck. Alright, so we're going to copy these guys to a new folder. So we'll create a new folder, and we'll name it just original. Alright, so it's just the version of alright, I've already copied my files there, so just paste it there so that you have a backup if you mess up. Alright, so we'll go into shapebot.properties, and this is the preferred program I use to open it with is WordPad. Notepad works, but it's a little bit more comfortable in WordPad. Alright, so here we have our things that we need to change. The first thing we need to change is shapebot 5 deck. That 5 stands for 5-axis CNC machine. What we're going to use is a 3-axis CNC machine. So we'll change that to 3, this one to 3, and of course these names need to match the file over here identically. Alright, so that's changed. Alright, the number of cuts, these you could modify to your preference of the board. How many deck cuts, rail cuts, and so the rail angle is quite an interesting one. I think it's the angle which Boardcad recognizes your board as being the rail. So if it's flat, then it's not a rail. If it approaches a 60-degree angle, it would consider it as a rail. That's what I believe it is. And then speed for cutting a board, change these to reasonable settings. They're all in millimeters per second. Oh, not per second, sorry, per minute. And speed reasonable for our machine, I'd say, is about 6,000. It all depends on your machine. Alright, extra parameters, cut stringer. If that's a 1, it means it's going to cut the stringer, which is usually it's made out of wood. So it needs to move slower. That's why we have the stringer speed over here. But of course, if you want to avoid cutting the stringer completely, you could change that 1 to a 0. So it's just some Boolean logic, which is 1 is yes, 0 is no. So I'll just leave it at 1. Stringer offset is, I think it's a bit of to separate your passes further away from the stringer. And then the cutoff is at the nose and at the tail of your board. It's going to plunge the cutter to chop off the excess stringer. So we'll just leave it at 30. This one I'd change to 0 because I want to cut the stringer as it is. Outline offset, that's just cutting the board out of the blank in the end. They're just offset from the board. Alright, the cutter, we'll go back to the cutter just now. There's quite a few settings we want to change to be able to use our own cutter in Boardcad. Okay, and then max height is the retract height for your z-axis, z-max height. Reasonable for our machine would be 250 millimeters. Alright, and now when we get to the machine settings, Boardcad, there we go. Boardcad expects the board to be placed in 2 supports and an end stop. Alright, there's a pretty cool diagram over here. I could also show a picture that I made using another CAD program, just of what it pretty much expects. So it expects 4 pucks to place your board on top, and then an end stop to zero your board against, so that it's correctly aligned. And then of course you could use whatever you want to anchor it onto those pucks. The pucks are there just for reference, because you've got an oddly shaped item that you need to place and then turn it around as well to cut the other side. The pucks seem to be the most acceptable. Alright, so machine support end X this would be your datum position for the board's tail end, 0 point. So I just set that as 0 because I just datum 0 my board at the 0 points. So that would be this position right over here. That would be 0 in height, 0 in width, and 0 in length. Okay. The distance for support 1, it's the distance from your end stop to the first support. I've got 300 here. So let's change to 300. The width between the supports, this dimension, that speaks for itself. I think that was 250. The height is the height of your puck above your 0 position. So I like to keep my 0 positions at the same height. So that would be at 0 as well because it's in the same level. Radius depends on the curvature of the dome of your puck. You could obviously have a positive dome, or you could have a negative dome that rolls in a socket. So the radius, I've got a diameter of 90 millimeters, so I'll change that to 45, which is the radius of that diameter. And support 2 distance is this distance from the end to the next support, not from the support to that support. So that would go to, I think that was 1,600. Really depends on your machine. Width between the support 250. Height of the second support is the same as the first support. So I'll put it at 0. The radius is also the same because I'm using the same style of puck, so that would be 4. And then these axes, I have not managed to successfully change them without totally confusing my machine code. So just leave them as is, and if you're designing a machine or setting up your machine, it would be best to have your firmware set up to recognize the length of the board as the x-axis, the width of the board as the y-axis, and then with the depth, thickness of the board as the z-axis. Alright, so leave that as that. Scanner settings we can leave, 4 and 5 axis settings we can also leave. So these guys are pretty much dependent on your machine setup, whether it's for a long board, short board, stand-up paddle board. So you'd obviously be changing these a little bit to accommodate different board sizes. And then the deck cuts is how many deck cuts there are over the width of the board. So for a bigger, wider board, you'd add more, and then also for a thicker rail, you'd also add more. Very much also depends on the resolution that you want with your cuts, and also your cutter's diameter, which we're going to set over here. Alright, so define cutter, this is where I've had the most trouble so far. But I'm going to try and make it as easy as possible. So here you can see the tool name is a flatcutter.stl. Alright, what an STL file is, it's just a three-dimensional model of the cutter that we're going to use. Take note that this STL has to be in the STL ASCII format, not the binary format. Okay, everything ahead of the hash is it's all comments, so it doesn't recognize any of it as a command. Alright, so the tool name that has been default selected is a flat cutter for 5-axis machine. So we can actually have a look at that cutter right over here. We can see the flat cutter 5axis.stl. Alright, so for our machine we want to select a different cutter that is more suitable. So what we can do is we can go ahead and type in whichever STL cutter we want from the list of available cutters. So let's say we want to use a standard bullnose STL cutter. So we'll go here, we'll change that to bullnose, and of course it's a file name, so it needs to be exactly the same. Same caps lock, same spelling, no spaces, identical. And the scaling of the tool, if the bullnose is scaled correctly, then you just leave it at 1. Alright, so we'll keep it the standard bullnose size. Of course, this bullnose is a little bit of a different size than yours. This one is, I think it's a 31 millimeter in diameter, and it has a radius at the corners of about, I'm not too sure, I think it was about 11. Alright, so, but we'll show you how to create your own cutter. Alright, so now that is selected, we can go ahead and modify our next file. So we'll save this file exactly as is. Let's go out there, go back to Boardcad. Now we want to open shapebot 3bottom.py. So we'll right click, open with, and our favorite one is WordPad for now. There we go. Alright, so this is the actual code that is used to generate the Gcode from the three-dimensional file. Or we're not going to do any maths over here. All we're going to be doing is selecting the correct cutter. So as you can see here, under Create a Cutter, we have the cutter that is currently enabled is a standard cutter. It is the Boardcad flat cutter, but it's not an STL cutter. It's actually a cutter defined in the program. So if we don't want to use the standard cutter, so we need to enable our STL cutter. So we'll just comment that one out. Alright, of course if you want to use a standard flat cutter with a radius, you could just set it over here. Alright, and then the Boardcam cutters, there we go, we've uncommented everything for the STL cutters. Now it's going to go fetch the tool name from our shapebot.properties file, and then you can also scale it over here for a second time, really. So that's very important if you want your cutter to be recognized correctly. Alright, then we'll also go back to, we'll save this one, and then we need to open the same file and do the same modification for shapebot 3bottom. Alright, but let's just take a moment here. There's another interesting one over here, stringer offset Z. Alright, you'll notice that once you create your first Gcode, leaving it at this setting, it would cut your stringer with 3 passes, each time plunging 5 millimeters, which is the difference in height over here. For my board, I only wanted to go through the stringer once because I have no stringer, so I'll just modify this little array to 0. Alright, and that should do the trick. It would only do 1 pass over the string. I'll save that. Alright, let's open the shapebot 3 deck. Alright, it's already selected for. There we go. And we're going to do exactly the same modification. So we'll remove hash there, hash there. Alright, so now you've uncommented the standard flat cutter and we've enabled the STL cutter. Alright, that STL cutter is going to be fetched from the file name in our Boardcad, in our shapebot.properties file. So we'll save this one as well. I also only want to cut the stringer once, so I'll change the array over there. So we'll go to finish that up. Alright, now we can pretty much go generate our first G-code using the standard bullnose cutter. Of course, your bullnose is not the same, so we'll show you how to do that in a moment. Alright, so the next step in Boardcad is to make sure that our blank is positioned on our pucks correctly. So we need to go to 3D model, and we need to go to transform and use the command place blank. It's indented there, so it means it's working. It doesn't show working or a little bar anywhere, so that's your indication. So when you place your board down for the first time, you're going to place blank, and then later we'll flip the board and we'll place board, because it's now cutting on the board surface, not the blank surface, as most of the blank has been cut away. Alright, so now it's been placed. Because it's at 0, it's still in line with our 0 origin point over here. So it's aligned our blank, the blue line, onto our pucks. If you have a bit of a rocker, you'll see it's adjusted it and placed it down there correctly. And now, yeah, our blank is placed, our board is still inside our blank. Now we're going to generate our first G-code. So we go to File, G-code, and then NURBS to Gcode deck, because that's our first file we want to cut out now. Take note, my board is flattened out on the bottom rocker, so that's why it looks a little bit funny. So NURBS to Gcode deck. We choose our file we want to save it, so we'll save it as deck.nc or text or CNC or whichever extension your Gcode interpreter uses. So I'll just go with NC. Alright, now wait for a moment. It's going to give us a dialog. Finish Gcode generation. Okay, now we want to see what the Gcode looks like. So we go right click again, view deck toolpath, and there we go. Now we can see our board has generated quite a nice toolpath here. Alright, and then on the side it's also important to have a look to make sure that it's retracting above the board and it's not doing any passes going through the board. So that looks quite good. Alright. There we go. You can see it has a little bit of a quick turn there, but it's just because of the shape of the board. Obviously, well, you'd actually want to slow your machine down if you've got a lot of complicated curves for your machine to part. So we'd go back to the shapebot.properties file to set a more appropriate speed also for the profile of your board. If it's got very jagged lines, you'd want to run it a little bit slower to avoid it from skipping any steps. And then of course, it looks like we've got a fair amount of passes on the top, so we'll reduce it a little bit, or really depends on your cutters, or maybe let's increase it. So we'll increase it to about 25, and we'll save the file, and okay, it's used by another program. Alright, so usually Boardcad would not hold on to the program. So let's just try again. See if it would save it. Oh, there we go, now it's saving it. Alright, so sometimes it helps to try again. We want to add some more deck cuts. We'll add 25 deck cuts. Let's reduce the rail cuts to about 6. Save, and I'm going to show you how you can see the G-code generated again. So save, close, go back to Boardcad. We'll do exactly the same. G-code, NURBS to Gcode deck. Choose the same file, we save it, wait a while. And of course you could modify your G-code as much as you want in shapebot.properties until it's satisfactory. So click OK. There we go. You can see it's gotten a little bit denser, but it's also worth noting that it's cutting a very wide path around our stringer over here. But that I've noticed it's very dependent on your cutter that you define. This bullnose is a very big diameter. It's 30 millimeters. So usually you'd probably be using a 20 millimeter, or depends on what you could get your hands on. If you've got a good source for nice foam cutters, I'd be very interested. So let me know. At the moment we're using standard spade bits and building our own. So now let's quickly flip our board and generate G-code for the other side. So what we're going to do now is going to 3D model, transform, flip board. We don't need to flip our blank or move our blank alongside because our top side of the board has already been milled. So we're going to replace it on the top side. So we'll go to 3D model and we will place board. Very important. Alright, taking its time. You can see it's loading. Is it working? And your shapebot.properties. If you're having trouble placing it, one of these settings, certain combinations of these settings could have turned out that your board is not being placed. And of course your board is being placed on these parameters that we've entered under the machine settings in shapebot.properties. Alright, we can see it's still busy. There we go, we can see it's moved. This point of intersection is most likely our puck position that we've set in shapebot.properties. You can see on this side as well. Alright, so that's pretty much where you're going to have the puck. Now this Gcode that we see over here looks quite funny, so we'll just go ahead and disable view deck toolpath. And we have not generated bottom toolpath, but we could just select it so that we can view it as soon as we've generated it. So now we do exactly the same. Gcode, NURBS to Gcode, bottom dot NC, pretty much the same format you want to use there. Save it, and 3, 2, 1. Finish Gcode generation. Alright, cool. So that Gcode has also been generated. You can see it runs across. To have a look at our Gcode in a bit more detail. Alright, looks like it's doing some mildly funny things over here. It's probably just because of the cutter size. But of course, if we change the cutter to a different one, our own STL cutter, we could get better results. Alright, also take note, if you're going to save it, it won't exactly save it as the same setting with the Gcode, with the board placement. You're going to have to do it again pretty much. And I hope my tutorial's been helpful so far. Just as an extra section, I'm going to show you how to create your own cutter. So first of all, we want to create an STL file. So this STL file we could actually open in Meshmixer, which is a free software from Autodesk. So creating STL files is also possible. Let's just open our bullnose. And we can have a look how it looks. Alright, so this is what the cutter looks like that we've just generated our Gcode with. And then in this program, what you could do is you could also do a little bit of a measurement. We could have a look at how big this cutter really is. Just get a rough estimate. There we go. Now we can see it's about 30 points. I'd round it off to 31 millimeters. We could also determine our radius by figuring out the dimension down at the bottom. So this dimension to, you could use Meshmixer to try and find out what your STL's dimensions are. And to create a cutter, you could probably create a primitive. This looks almost like a cutter. You could learn how to use Meshmixer and create your own cutter, but I just stick to my usual CAD program, which is Autodesk Fusion 360, which is free to hobbyists, and that fits my category. So I'm just going to create a new design. And in here, I'm just going to create a mock-up of my cutter. So I'll just create a cylinder. And I believe the axes, this would give me the correct axes. So I'll just turn it. Diameter of my cutter is 20 millimeters. I'll extrude it to, just make it long enough. Alright, and I'll add a fillet to the cutter. That's a bullnose, and I think it has a radius of, the radius is 4.5, so there we go. So that's pretty much what my cutter looks like. Well, it's that simple. You could also pretty much create almost any shape you want, I believe, but I have not tested the extent of this. So we'll go to body, we'll right click, save as STL, and we make sure that the format is an ASCII, not binary. Binary doesn't work in Boardcad, so we'll choose ASCII. And we don't need such a high resolution. STL is very common and used in 3D printers. Alright, so we'll just save it as our cutter, which is a 20 by 4.5, can't exactly put a point there, 45 millimeter, bullnose.stl. Alright, save that. Cool. And now what we can go back to our program files and also our board directory. We want to copy this guy, paste it alongside our other cutters. Alright, and then in our shapebot.properties, we want to change the name over here. Our bullnose.stl. So our name that we made it was a 20 by 45. So double check. Millimeter bullnose.sti. Millimeter bullnose. There we go. Alright, so that's our cutter that has been created and implemented, but I just need to make sure that my cutter is in the right shape. So just for safety's sake, I'm going to import it alongside this original cutter just to make sure it's in the correct orientation. So there we go. So if you have a look here, you can see it's pretty much in the same orientation. If it was sideways, we just have to rotate it just to make sure it's good. Pretty much like the cutter I'm going to use. So brilliant. That's double checked, and now we can go back to Boardcad and generate our Gcode again. Nobs to Gcode bottom, and choose bottom here. Oh, probably just got to save this guy here. Let's run our Gcode. Alright, now let's have a close look. See, it's going to adapt. There we go. That toolpath looks a lot nicer. Alright, really depends on the cutter you use. Obviously I've got a much smaller cutter now, so plays a bit of a role. There we go. Alright, so that's how you can use your own cutter in Boardcad and generating Gcode for top and bottom. And yeah, make sure you set up your machine correctly, place the board correctly, and then you should have satisfactory results. Thanks for watching, and I hope it helped. Give it a thumbs up if you could use it. Alright, thanks guys.